One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So right now we are going to be getting into the graphical illustration as long awaited. We're going to be using the Excalidraw to a bit scale. That's not a scalar, right? A scale to see how this function works, how the Morris transversal works. And yeah, there is a caveat at the end of this series, not at the end of the Morris transversal, right? So stay tuned for that. So let's get into it. So we call the current node to the head of the guy. So we put that back here. We have our, what's it called? Come here, pick it up. So let's just point it away for now. Now we say while current, so while the node is not none, so we say if current the left is none, so current the left is none, so we can skip that block. We say else predecessor is current the left, so pick this up. This is now a predecessor. Sorry. So we say while predecessor dot right and predecessor dot right is not current, that we should go iteratively to the predecessor dot right. So basically what that is saying is go to the right continuously, right, up until we get to a point where the predecessor dot right is not, it because it's none. So we say predecessor right. So while predecessor right is none. So we see that here predecessor right is none. So we can stop our iteration here and point our pred this guy to, and as this guy is done at that point. Now we now say if predecessor right is none, just as we have that we want to predecessor right to point to current. Now it's pointing to none, so we point it away from none and we point it to current. Now when we do that, we down say predecessor sorry current dot left. So current will now move away from this guy and becomes the left, right? That's the first instance, and our code block is done. Now we come back to the top again and we say if it's while current, so is current none? Nope, it's 2, so we still vibing. So we say if current dot left is none, print current. So current dot left is obviously not none, so we move on. We say else predecessor is current dot left, so we pick up predecessor from here. Yep, we put it to this guy, right? And then we say predecessor left, so we now say while predecessor right, so we say this guy to the right shouldn't be the none. If it is none, we break out of this while loop. So this while loop is not applicable here because our right is already none. So we move on from that guy. Yes, and because it says and predecessor right is not current. Obviously, none is not current. Current right now is 2. So we move on and we say if predecessor right is none, which is satisfactory because right now is none. And so what do? We say predecessor right should be equals to current. We pick this guy from here, point it to current, right? And what do? Current becomes left. Let's continue. So now we have our current as the current dot left as we've done here. So that satisfies this situation. So we run back to the top. So what's our current? Our current right now is 1. It is not none. So we continue the while loop, and we say if current dot left is none, print current dot value. Is current dot left none? Yep, it is none. We see that the left is none. So it says we should do what? Print current dot value. So basically to update our print again, let's take out all these guys. Now what's value is 1, so we print that guy out and we chill and we see what the next stuff is. So after doing that, it says print it out, then we should do current dot right. So current dot right at this point is taking us to 2, so you say we should point our current to back to 2. Now we point that back to 2, and what happens? It says okay that we're good, so we're done. So we go back to the top. It's 2 none, it's not none, so we continue on the while loop. We say if current dot left is none, current dot left at this point is no longer none because we are 2 and left is 1. So we continue on this guy. So we say predecessor is current dot left, so predecessor points back to it's already existing in current dot left, so we chill. So what next? What next? Okay, so we say if we say while predecessor dot right and predecessor right is not current, that we should say predecessor dot right. So predecessor at this point is not none, so we should be able to move. But predecessor dot right current, yes, predecessor right is pointing to current, so we can't, this thing is not satisfied, so it is pointing to current, so we have to skip over it, and we say if predecessor right is none, so it is not none, right? So because it's not none, we look at the else state. We say predecessor right should become none, so basically we take this guy back here into none, and what did he say? We should print out the current value, which is 2, so we print out 2, and then what else? We say current dot right. So now current, we pick it up. No, that's not what we asked you to do, Murefe. So we take it here to the right, which is 3. Now we continue again back to this guy, where we look at the top. We say while current is not none, is 3 none. Nope. So we continue. We say if current the left is none. So current the left actually is none. Yeah. So what do? You say we print out that guy, and yeah, let's print out that guy first, right? Now, when we print out that guy, what do we do? Yep. So it says what we should move our current to current the right. So we printed out this guy. Now we can move here. Now if we move here, what does it say? We should break out and check if our current is none. So we check if our current is none. Nope, it is 4. So we move on. So now we moved on, we get to else. Wait a minute. Why do we choose else? Because current the left is not none. So we go to the else bit, predecessor becomes current the left. We fill it up, put it there. Yep. So we say while predecessor right and predecessor right is not current. Right. Why predecessor right and predecessor right is not current. So is predecessor right none? Predecessor right is not none. Is it current? Nope, it's not current. So we skip over that guy. We say if predecessor right is none. Okay. Wait. Okay, this is predecessor. So you say predecessor, that this guy is not none, and if predecessor right is also not current, that we should be able to move. So we moved here. So we now say if predecessor is none, it is not none. Is the right current? Yes, it is current. So it breaks the loop. So this way our predecessor should be at this point. So we don't ignore this guy. We actually adhere to it, and it helps us move one place down to 3. Right? So we now say if predecessor the right is none, actually it's not none. So we go to the else bit and we say else the right is equals to none. So we pick this guy back up here, put it at none, and then what do we do? So predecessor current dot value should be printed out. So that's 4, right? Now current dot right. Current is equals to current dot right. Pick it up, put it at 6. So we see this iteration and we see how we handle the left, and that's actually what is going to go down again in the sorry, how we handle the left. So we are going to also handle the right in the same manner. So we could go through that bit again, and yeah, we will still get the same values. So yeah, we're just going to brush through that, where we would have our predecessor right, and then we move it down to the bridge to the left, and then we see that this is none. We point it back out to this guy. This guy comes down here, checks the left, prints this guy, and yeah, gets back, prints out this 5. The 5 gets the predecessor back here to point it back to none, get this guy back to 6. Same old. Yeah, basically not yet. So this guy is supposed to be fair here, yes, first. This guy is going to be printed out. Then we move this guy back to 6, and then after all said and done, we bring this guy here and then print out 6. So by the end of the whole stuff, we're going to get 5 and 6. Yep. And then we come back to the 7, the same story, and we get 7. Yeah, so basically that's the Morris transversal. We see that we don't make use of any stack here. We don't create any new storage. We just use the tree itself to remember where to go back to after a sequence of events, and basically make use of it to deliver our Inorder transversal. And that's basically it for this graphical illustration. Hope it helped us to grasp exactly what Morris Transversal is all about, how it helps us meet the requirements of the question. And yeah, so next up is going to be a debugger tool illustration again to help now solidify what we've learned. We now see how it goes through the function and how it still delivers us the print as it should be. So yeah, see you on that one. Muchas gracias. Choose.